Hey guys, today we will have a lot of fun. Today we will be talking about introduction to NumPy, numerical Python computing. Guys, you know that Python is heavily used for scientific computing, and in the scientific computing for research purposes, we require a huge data, and in the huge data there is multi-dimensional data. And normal Python arrays are not sufficient to play with this huge data, multi-dimensional data. So there is a special provision called NumPy, numerical computing with Python. So guys, don't please, and my appeal to you people, please don't forget to download the PDF. I'm giving you the very beautiful PDF. This has been made with a very lot of efforts. Color beautiful PDF. This is my gift to you people. That please do the hands-on sessions from this beautiful PDFs. You download it and try to do the programs, because because everything I cannot cover in my tutorial, in video tutorial, because length becomes more large. So I appeal you people to download such PDFs I am giving with the tutorials and do the hands-on sessions. Guys, as far as this numerical Python computing is concerned, as I told you, there are several plethora of functions are available to play with, to have fun with arrays. I'm Dr. Nilesh, Shelke, Assistant Professor from Priyadarshini Indira Gandhi College of Engineering, Nagpur. This is how one-dimensional array is. This is two-dimensional array, and we also work with three-dimensional array. You can see there is a plethora of functions. Arrays functions which we can use for creating arrays. A linspace is there, function which is used to create arrays. Arrange is there. Log space is there. Zeros is there. Ones is there. Full function is there. Empty functions is there. I functions is there. These are so many functions with which we can create a with array in our Python. So let us start doing here. The very first function that you will type is import NumPy as NumPy. You may say NumPy or NumPy as NP. NP is just an alias or a variable that we are creating instead of writing NumPy every time. So let us create array, write array, and just say dot, and Jupyter will show you the functions that are available with this array we are using. So let us tell array that how many columns and how many, suppose you are directly giving, suppose give the array in the square brackets. Suppose you are saying 1, 2, this is first and second component is 3, 4, right? So let us print it. You know, in Jupyter last variable, it default printed. It did not to say print, and this is how it has printed the array. So this is how, with the help of array function, you can directly create array. Guys, we have another function with a arrange name, arrange. With that also you can create array. Let us use that. This is very simple function, range, and you just give the number. Suppose you want 10. Okay, so it has created array elements with 10 numbers. Okay, now this is single dimensional array or rank 1 array. Suppose you want to create rank 2 array or double dimensional array, you just use the reshape function there. Just say reshape. Suppose let's copy this code here and just say reshape to it, and tell how much reshape you want. Suppose array 5 by 6, 5 rows and 6 columns. Obviously it will be 30 elements. So let's just take it. You have seen that such a simple function it is, arrange. Similarly, you can have three-dimensional also, rank 3 arrays also. Just give suppose right in suppose we take 2 matrices of 2 by 2 rows, so there will be total 8 elements, right? And you want 2 matrices of 2 by 2 size, right? So this is how you have seen that it has, this is 3-dimensional data, 2 matrices of 2 by 2 types. This is how you can have functions, reshape function. And you have one more function with zeros. Directly say np zeros, and you just tell figure to it 3 by 4. So it will array AR. This is how it will print the np zeros. So what is the mistake? Okay, this is a function, and you have to give it in a bracket. So this is how you can do it simply once also. use ones function there. So it will give the 3 by 4 matrix with one element. Let us move ahead and try another function. We have empty function also. With empty function, what it will do is it will create a random numbers between 3 and 4. Suppose you are giving 3 and 4, it will create the random number. Sorry, one more bracket should be there. It will create the sorry, some mistake is there. Let us use another variable, array1. Let us change the dimension 2 by 4, suppose. Sorry, one square you forget. So this is how what it is doing is it is creating the random numbers. Okay, this is how you can use empty function. Then we have full function. Let us move ahead. Full function. What it will do is it will create the array what of the dimension you want. Okay, suppose you want 3 by 4 array with 3 by 4 dimension, and you just give it the element that particular element only will be repeated in all those rows and columns. So you can see here I have asked it for 3 rows and 4 columns, and I am saying 5 number. 5. If you want to 6, it will give 6. That means whatever the elements you want to repeat, you can give. Again, I have one function with I, identity matrix. It will have a no, I, suppose I is equal to np dot I is just a variable in first case. So what it will do is it will create 4 by 4 row of diagonal elements will be equal. You can see that it's identical matrix of the size 4 by 4. Similarly, we have one more function, beautiful function with a linear space. Let us see it. You just say np dot lin space, and you give starting number, ending number, and one number. What it will be doing is from starting to end number, it will create regular pattern, regular element. What I mean to say, in this case, it has taken 1 to 10. It has gives me 8 parts, 8 regular parts, a regular interval. It is actually you can say it as a step, but exactly not step. It will give me the 8 elements interval between 1 to 10. I hope it is clear to you. Let us move ahead, and we can create a array from the list also. Suppose you are taking list, take random numbers. Suppose I am taking these many numbers, and now if I asked to create an array from it, so suppose lst is a array. I am giving the name, and you just say np dot array and give just list. So from this list, you can create array. Let us print this list. I mean array. So this is how you have printed the array. So this is so easy. Let us use last function, log space, and let us understand what does it is. What is it? Suppose this is somewhat difficult, maybe difficult to you people. I say np dot. Suppose I am assigning to a. A is equal to np dot log space. Log space interval, starting interval, end with number of elements. I want 5, and suppose I am saying base is equal to 10. Okay, let us understand it, and suppose I want to print it. Now let us try to understand what it is doing is it will take 2. It will start 2 to 3. That means it will take the numbers between log of 2 to the base 10 to log of 3 to the base 10. Not necessarily you can take the base as 11 or any number. Just an example, I have taken 10. So it will give me the numbers between log of 2 to the base 10 to log of 3 to the base 10, and the 5 numbers in between. Suppose you want 10 numbers, you just say 10 numbers. Okay, that means again I repeat, let's spare some moment here. It is giving me the number from log of 2 to the base 10 to the log of 3 to the base 10. We want 10 elements. Okay, so this is how it does. So I repeat, array facility NumPy gives us a very very easy way for handling the arrays. array function is there, linear space is there. You just give starting to end, and you just give the number how many elements you want. Arrange function is there, log space is there, zeros is there, ones is there, full function is there, empty function is there, and I function are there. Guys, I will appeal you hands-ons, do the hands-on sessions, do the practice, download the PDF which I have given you the notes. Please subscribe the channel and share with your friends, so that if you have any problem, difficulty, then your friends can be of help to you. Thank you very much.